Let's look at circuit theorems. Okay, when you talk about circuit theorem, there are angle properties in a circle. Okay, so we are going to look at the properties forming a circle, and then we have a lot of theorems. Okay, we will learn them, and that will help us solve questions with angle properties in a circle. But before that, let's know some important parts of a circle that will be needed in solving the question. Not all the parts, but some of the parts. Okay, so we have our circle. Distance around the circle is called the circumference. Circumference. And the center of the circle to a line from the center of the circle to the circumference of the circle is called the radius. And then a line that passes through the center from one end of the circumference to the other end is called the diameter. So what we should take note is that the radius is half of the diameter, or the diameter is twice of the radius. Okay. Then, if the line doesn't pass through the center, but from one end of the circumference to the other end, we say it is a chord. So a straight line from one end of the circumference to the other end is a chord. If it passes through the center, then it's a diameter. Then, any portion of the circumference of the circle, so let's say my chord here, we have AB. Let me shade this place so that what I'm talking about will be simple for us. So any portion of the circumference of the circle is called an arc. So let me take this, just this particular place. This is an arc. And then from here also to here is also an arc. But the arc, you have the minor and then the major. So that means this becomes the minor arc. And then the unshaded place also becomes the major arc. So an arc is just a portion of the circumference of the circle. And one thing we should also note, or that we should know, or it will help us, is also the segment. Okay, we know this is a chord from here, and when you see that the chord divides the circle into two, but not two equal parts. So if I have a chord here, the lower part of the chord here, okay, is a segment. And the upper part here is also what? A segment. But the side that is small is the minor segment. The bigger part is the major segment. Alright. So if it's a diameter, and because diameter passes through the center, it will divide it into two equal parts. And we have a semicircle, that is half of a circle. So semicircle, semicircle. Alright, but because if it's a chord, it doesn't divide into two equal parts. You may have a segment, and you have the major segment and then the minor segment. And then one thing that we can also look at, let's say, maybe a sector. A sector. A sector is also a portion of the area. The space covered by the circle is the area of the circle. So a sector is a portion of the area. So let's say, let me shade this particular place. This place becomes what? It's a sector. But so we have the sector here, and the sector is formed by two radii. So radii, radius, radius. All right. So a sector can be like this. You see, or a sector can be like this. O is the center. All right. So when you look at this, the shaded portion is a sector. The unshaded is also a sector. Okay. So a sector is formed by two radii, and it's a part or a portion of the area of the circle. So the smaller part is minor. The bigger one is what? The major. All right. So I think these are some key or important parts of a circle that we should take note of. We should take note of. All right. So now let's go straight. So if you have gotten the parts of the circle, let's go straight to the properties. All right. So we are going to look at least 7, 8, maximum 10 theorems. Okay. So now, I'm just going to explain, draw the diagram, use it to explain it to you. All right. So number one, what the theorem states is that if we have a circle, the angle that is formed at the center of the circle from an arc or a chord is twice the angle that is formed from the same arc or a chord at the circumference of the circle. So let's say this is my circle and this is my arc AB. Alright, so we can see a chord. Okay, so the angle formed at the center. Okay, so let's say I have an angle at the center, theta. The angle formed at the center, if O is my center, from this arc AB or this chord AB, we say that it is twice the angle formed from the same arc or the chord at what? At the circumference of the circle. So from this arc or from this chord, what is when do we say an angle is formed? An angle is formed when two straight lines meet. So from this arc or from this chord, two straight lines are meeting at O. That is the center. From the same arc or the same chord, two straight lines are meeting at the circumference. So what we are saying that if that happens, then the one at the center is twice the one at the circumference. Okay? So if that is the case, when you divide this one by 2, you get whatever is here. Alright. So in reality, here will be half of what? Half of theta. So whatever is here, when you divide by 2, you get it. Or whatever is here, when you multiply by 2, you get what is here. Alright. So let me use an illustration here so that you get what I'm saying better. So let's say here is 120 degrees. If here is 120 degrees, then what happens? Then what is going to happen is that here is going to be what? 60 degrees. So if here is 120, then here is going to be 60. Because the angle at the center, so let's say here is the center, from this particular arc or this chord is twice the one at the circumference. So what it says is twice of this. Or sometimes you can be given here, if here is also half of this. So if I multiply here by 2, I will also get this one. Alright. So if here is 120, here will be 60. If here is 60, here will be 120. That is what we are talking about. Let's also look at something from the same example. And we can see from here, okay, we can see from here that this is a radius, this is a radius. Because you said this is a center, so from the center to the circumference radius, from the center to the circumference radius. So when it happens like that, then here becomes a radius and here becomes a radius. So what happens to the triangle? Triangle A, B, and then O. So from the chord A to B, so this is the triangle. And this place is the same as this, radius and radius. So it makes this triangle what? This triangle becomes isosceles, because two sides are equal. So if that is the case, when you come here, let's say here is 120. What is the sum of the interior angles of a triangle? If this, because this side is the same as this side, alright, then what is going to happen? If here is 120, 120 plus 60 will give me 180. So it means this angle plus this angle will give me the 60. So here will be what? 30 degrees. And this angle will also be what? 30 degrees. So that 120 plus 30 plus 30 is going to give me what? It's going to give me the 180. So because when it happens like that, take note that the triangle becomes isosceles. And the angle here, okay, this particular angle become the same and the base angle become the same. So these two angles become what? The same. So here, this particular angle here become the same as this angle. So that is one of the things you have to take note, and it is very, very important. Alright. So we are done with the one. Let's go to the two. The number 2, we are dealing with the same thing. But here, you realize that in the first one, okay, we use what do we call it? A minor arc. Okay, in the first one it was a minor arc we used. It was a minor arc. And then the arc was sustained an angle. Okay. So the first one, we said that if the here is the center, then the angle here is what? Is twice the one at the circumference. So the angle that sustained at the center is from the minor arc. okay, the minor arc. However, if the angle at the center is here, is a reflex, okay, let's take it, my angle here, the minor one sustained here, so the major one will also sustain here, which become a reflex angle. So the angle also here, also sustained by the major arc, is also twice, all right, the one is subtends at the circumference. So here will also be half of theta. Okay, so if it's a major arc, this, then the reflex angle here, okay, we know that here is twice the one that is sustained at the circumference. Also here, the angle here, if this place at the center, then the angle here is also twice the one it will sustain at the circumference here. Or this is also half of this. All right. Let me use a typical example so that you will understand what I'm saying better. We will use typical example to prove all the two. So look. So let me use the first angle at 120 degrees. And we said that if here is 120, let's say here is the center, then what happens here? So here is AB. Then the angle here becomes 60. So this is twice of this. Alright. Then what we are also saying from this particular place is that the reflex angle here, okay, is also the twice of what the circumference here. Okay. So whatever you say is also the twice of here. Alright. And what it says is twice of here. Okay. So let's see something. If here is 120, then what will be this angle? This becomes an angle around a point. An angle around a point is 360. So 360 from 120 is going to give us what? It's going to give us 240. So the angle here will become 240 degrees. Okay, 240. And they say this is twice of this. This is twice of this. So what we are going to divide 240 by what? 240, we are going to divide it by 2. And when we divide 240 by 2, what are we going to get? I think that is 120 degrees. Alright, so here will be 120 degrees. The angle here will be 120. So what is here is also twice of this. Don't assume that this is the same as this. Alright, no. It's just the example that we used. Okay, except here, this quadrilateral here, okay, may be a rhombus or it may be a parallelogram, and if that happens, then the opposite angles become the same. All right. So here is also twice of this. That is what we are talking about. That here is twice of this one. All right. So that is the number 2. Let's move on to number 3. Okay. Number 3 here. What we are also saying is that if you have a chord, okay, if I have a chord or an arc, so an angle that's sustained at the circumference of the circle from the same chord or from the same arc are equal. So if I have an angle here at the circumference, so you see that they are from the same arc or they are from the same chord. So if my angle here is angle X, then from the same arc or the same chord, because I have another angle sustained at the circumference, then here the arc here also be the same angle. We can also have the same thing, the same chord or arc. So here also be the same angle X. But here please take note, it should be in the same segment. I believe you understand segment. This is a chord, so this is one segment, this is another segment, so the major one and the minor one. So, but not the opposite segment. So if I bring an angle at the circumference here, it won't be equal to this one. They should be in the same what? In the same segment. That is what we are talking about. So typical example of that is if here is 50 degrees, then the angle here can also be what? 50 degrees. That is what we are talking about. Okay. So don't assume that the angle here is also 50. No, it is not so. Okay. Let's go to number 4. Number 4. But in number 4, there are another problem. We are saying that let's say you have a diameter. I have a diameter. Here is the center. If I have a diameter, then the angle that's obtained at the circumference of a circle from a diameter is equal to 90 degrees. So here it's 90 degrees. Here is going to also be what? 90 degrees. Because this is a diameter and the angle is obtained at the circumference here. The diameter angle is obtained at the circumference here. So here will be 90. And because this is also a diameter, the angle circumference will be 90. So an angle that's obtained at the circumference of a circle from a diameter is equal to 90 degrees. Okay. Let's see another property. Okay. Another property is also saying that if I have a circle, all right, there, and then I have a quadrilateral in the circle, we call it the cyclical quadrilateral or the cyclic quadrilateral. That is a quadrilateral that touches all the vertices, touches the circumference of the circle. So quadrilateral is a four-sided figure. So like this. Okay, let's say the vertex A, B, C, and let's say D. Okay, so there's a cyclic quadrilateral because it is touching all the vertex touching the circumference of the circle. Okay. The opposite angle of a cyclic quadrilateral sum up to 180 degrees. So if I have an angle here, an angle is here. If here is A and here is B, then my A plus B should give me what? 180. The opposite angle. If here is X and here is Y, then also X plus Y will give me what? 180 degrees. So the opposite angles of a cyclic quadrilateral add up to 180 degrees. So X plus Y will give you 180. A plus B will also give you 180 degrees. That is what we are talking about. And look here. That is what happened here. Okay, we know that from a diameter, it's after an angle of at 90 at the circumference. You see, so 90 plus 90 is going to give us 180. You get it? Yes. So this angle plus this angle, because it's a cyclic quadrilateral, and you say this is a quadrilateral, 1, 2, 3, 4. Then the opposite angles will add up to 180 degrees. Okay. So a typical example can be, let's say something like this. If here is 70 and I'm asked to find A, then A plus 70 is going to be 180 degrees, and my A is going to be A 180 minus 70, and my A 110 degrees. So here is going to be 110 degrees. So that the 110 plus 70 will sum up to 180. That is what we are talking about. Number 6. Number 6 here is also saying that if I have a circle, the exterior angle, okay, is equal to the opposite interior angle. So let's say I have a circle. When I extend this, I get an exterior angle here. Okay. So let's say here is A, B, C, and D, and here is E. So A, B, C, so I have A, B, C, and D, and my exterior angle is what? Is here. Okay. Then what do we say? We say that the exterior angle here, the E here, is equal to the opposite interior angle. So the E here is going to be equal to what? Is going to be equal to the B. And why that is the case? That if I have a cyclic quadrilateral, the exterior angle of the cyclic quadrilateral is equal to the opposite angle of the quadrilateral. Okay, so the exterior angle of a cyclic quadrilateral here is equal to the opposite angle here. And why that is the case? We know that B plus D is going to give me 180 for cyclic opposite angle, and this is a straight line. So D plus E will also give me what? 180. And this is 180, this is 180. So I can say that B plus D is equal to D plus E. Okay, and then what do I say next? D is here and D is here. So when I bring this here, D will be D minus D. That is D and D will go. Therefore, B is equal to what? The E. That is what you are talking about here. So when I have a cyclic quadrilateral, the exterior angle here is equal to the opposite interior angle. Let's say I extend this. If I extend this, then what am I going to get? I'm going to, let's say I extend and I call it what? F. The exterior angle here will be equal to the opposite interior angle, which is what? F is going to be equal to the D. Alright, let's assume that I extend this one also. And this one is J. The exterior angle here is going to be equal to the opposite interior. So my J is going to be equal to what? It's going to be equal to the C here. Is that okay? I believe you get it. Let's say I extend this. I call here H. The exterior angle here is going to be equal to the opposite interior angle. So my H is going to be equal to what? It's going to be equal to the A. So that is about this one. Alright. Number 7. Another property here that we have to learn is that if we have a circle and the circle has equal chords, okay, so this can be one chord, this can be another chord. Let's say this chord is equal to this. They are saying that if that is the case, then the equal chords will sustain the same angle at the what? At the circumference. So if here is theta, then here is also going to be theta. Because the chords are the same, they will sustain the same angle at the circumference of the circle. Let's also talk about this. The same, if I have equal chords, then this same equal chords will sustain the same equal angles at the center. Okay, at the center. So if this angle is M, then here is going to be M. So what we are also saying that if, let's say O is the center, if the chords are the same, then they will sustain the same angle at the center. So here theta is theta, M is equal to M. Okay, so that is what talks about equal chords. Equal chords sustain the same angle at the center, the same angle at the circumference. All right. 8. Let's talk about this. Okay. If I also have a circle, and with the circle, I have a radius. Okay, so let's say this is my radius. This is my center. What we are saying here is that, and I have a tangent. So this is my tangent. What is a tangent? A tangent is a line that touches a circle at a point. Okay, so the tangent touches, it is tangent to the circle at, let's say, the point A here. So this is a radius. Okay, what we are saying is that a radius is perpendicular to what? To the tangent. So the angle formed, okay, at the point of contact between the radius and the tangent is 90 degrees. So when you have a radius and you have a tangent, the angle formed at the point of contact between the radius and the tangent is what? It's 90 degrees. It's 90 degrees. Okay, that is about radius and a tangent. Radius and a tangent. Okay. Okay, so let's talk about let me say the last one I want to talk about. Okay, so let's talk about this property also. This property is that the angle between a chord and a tangent is the same as the angle that the chord sustained at the circumference of the circle. So let's say I have my circle here. This is my tangent. This is my tangent. So the angle between the chord, okay, the chord, this is the chord, and the tangent. This is the angle between the chord and the tangent. So let's say angle M. It's the same as the angle this particular chord will subtend at the circumference of the circle. So the angle, this is the chord and this is the tangent. The angle between the chord and the tangent is the same as the angle this chord will subtend at the circumference of the circle. Alright. So here we can also say that, you see, this is also a chord. Okay. So we can say that the angle between this chord and the same tangent, if the angle is P, is the same as the angle this chord subtend at the circumference of the circle. That is the angle here, P. Have you seen that? That is the angle here, P. And you see, this is a straight line. So M plus the angle here plus P is equal to 180. Interior angles of a triangle, M plus P plus the angle here is also equal to 180. So you see how simple it is. Very, very simple. Very simple. Okay. And there's last one I want to talk about. The last one I want to talk about. That way we are going to look at if I have a circle and if I have a tangent, okay, two tangents coming from the same point, okay, there is a tangent. It is tangent to the circle at A, tangent to the circle at B. Two tangents from the same point, okay. We are going to look at some properties and then we close with this one. Okay, so we know that if here is the center, we have established that the angle between what? The angle between the radius and the tangent is 190. So here is going to be 90. So this is the radius. This is the tangent to the circle at B. And here is the center. So here is also going to be what? 90 degrees. So the angle, because this is a radius, the center, and this is a tangent. So here is going to be 90, here is going to be 90 degrees. Alright. And then what we should note is that because they are coming from the same place, okay, this from, let's say this is B, they are from the same point. So from A to C is going to be equal to B to what? It's going to be equal to from B to C. So this line is coming, is also the same as this particular line. Okay, so when it happens that way, and then here is length, okay, and this side is the same as this side, and this is radius, okay. So when it happens like that, then what it means is that this particular triangle is become the same as this triangle. The reason is that AC is the same as BC, and here R is the same as R, and we have the same length here, OC. So the angle here also becomes the same as the angle here. Okay, so this angle, if here is theta, it becomes the same as here also as theta. So the angle here becomes the same as the angle here. Alright. And you should take notice that if here is the center, then from our first property we established, then the angle here will be twice of this one. So if here is theta plus theta, okay, the angle here will be twice of this one. So here is going to be theta. So that when you multiply this one by 2, it give me 2 times theta, that is theta plus theta. Alright, so the angle here is twice of whatever we also have here. Alright, so this triangle here is 90 degrees. Okay, and this triangle can be same as this one. So I think that is what I want us to know about this. When you take the best grade series and you read, you get more information about this one also. See you for another lesson, and know that all the properties, when you revise them, or you can answer every other question. The more you answer question on it, the more you understand about the property. So as you've gotten these properties, answering question becomes so simple. See you for another lesson. Bye bye.